Today, we have an identity with two positive constants. The factored expression and the expanded quadratic agree for every value of x, and we need r minus p.
Here are the exact answer choices. Do not choose from the product alone. Because the factors treat p and r differently, the order of the pair will matter.
I notice 60 at the end, so my first instinct is to list factors of 60, but there are several pairs. How do I know which number is p and which is r?
Start by expanding carefully. Multiply every term, then combine the two x terms. This turns the identity into three coefficient comparisons.
The two middle terms combine to negative the quantity 2r plus p times x, so the leading coefficient is already 2, exactly as required.
Now match corresponding coefficients. The x coefficient gives 2r plus p equals 29, and the constant term gives p times r equals 60.
Pause here and try to find p and r use both equations. And remember that p is smaller than r. I will give you a few quiet seconds.
A quick factor scan is useful. The positive factor pairs of 60 include 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, and 6 and 10.
5 and 12 stand out because twice 12 plus 5 is 29. If p is 5 and r is 12, both the sum condition and the product condition work.
And the order condition works too. 5 is less than 12. We have not merely found two factors, we have assigned them to the correct roles.
Let me test the tempting reversal. If p were 12 and r were 5, then 2r plus p would be 22, not 29. It also violates p less than r.
That factor scan is fast, but let us also prove the solution without assuming p and r are integers. The problem only calls them positive constants.
From p times r equals 60, I can write p as 60 divided by r. Then I substitute that expression into 2r plus p equals 29.
Because r is positive, multiplying by r is valid. Move every term to one side and we get a quadratic equation in r.
The quadratic factors as 2r minus 5 times r minus 12, so r could be 5 halves or 12.
If r were 5 halves, then p would be 24. That contradicts p less than r, so this entire branch is rejected.
If r is 12, then p is 60 divided by 12, which is 5. This branch satisfies positivity, the coefficient equation, and p less than r.
Now compute the requested difference, not the sum and not either constant by itself. 12 minus 5 equals 7.
So choice D is correct. Substituting p equals 5 and r equals 12 into the original factors gives 2x minus 5 times x minus 12.
Expanding that expression gives 2x squared minus 29x plus 60, exactly matching every coefficient in the workbook prompt.
The main trap is stopping after p times r equals 60. A product identifies possible factors, but the middle coefficient tells us how those factors are weighted and ordered.
A second trap is treating identical expressions as if they agree for just one convenient x value. An identity holds for every x, so corresponding coefficients must match.
My three-step recap is: expand and collect like terms, match every coefficient, then apply the order condition before calculating the requested expression.
The final answer is choice D, 7. The decisive idea was using both coefficient equations to recover an ordered pair, not just an unordered factor pair.
This lesson is linked to the 5-year workbook as source episode 2021, Module 1, Question 2. Try the next problem before our next visit to the clock tower.